In this video, we're going to be factoring more polynomials. The methods of factoring that we're going to be talking about is factoring trinomials specifically, and we're going to be using the guess and check and AC method. A trinomial, as suggested by the name, is a polynomial with three terms or a sum of three monomials. Very important to keep in mind when we're factoring trinomials is this general form. So this would be where we list the trinomial in decreasing order of monomials, of their degrees. So, for instance, we always want to write it like ax squared plus bx plus c. This is going to help us when we are factoring. Some examples, and we're going to factor these. X squared plus 2x plus 1, x squared minus 14x plus 45, 15x squared minus 19x plus 6, 6x squared minus 7xy minus 5y squared. The first method we're going to talk about is guess and check. We're going to start with this example, x squared plus 2x plus 1. Now, this polynomial is of degree 2, so if we can factor this, we're going to need to write it as a product of polynomials of degree less than 2. Our only option for that are polynomials of degree 1. So it's going to look something like x plus a number times x plus another number. Now, notice that the leading coefficient of this polynomial, or this trinomial, is 1. We know then that we're going to need 1s in each of those terms. Because if we were to FOIL this back out, we would need to be sure that we get x squared as our leading term. Now, all that's left for us to figure out is what are these next two terms. So we know it's going to be x plus something times x plus something. Well, we also know that our last term, so here was our first term. We know that our last term, our last term is going to need to be 1. Now, what two numbers can we multiply together to get 1? Let's try a 1 and 1. And sure enough, if we do x plus 1 times x plus 1, and we FOIL this out, we get x squared plus x plus 1, giving us x squared plus 2x plus 1, which is what we wanted. Something nice about factoring is you can always check to make sure that the factoring you've done is correct. And that's what we did right here, is we checked, or we FOILed our factoring back out to make sure we get what we wanted. Now, this was a pretty easy example. Let's do something a little more challenging. X squared minus 14x plus 45. Another thing to note is that, again, the leading coefficient, or the term on the monomial, the coefficient on the monomial of degree 2 is 1. Now, the guess and check method works best when that's the case. If you get something like 2 or 3 or some other that's not 1, you may want to start with a different method that we're going to talk about next. But again, when we have a leading coefficient of 1, we're going to take a guess. We know it's going to look like x plus something times x plus something else. What we need is we need our last term to be 45. So we need the product of this and this to be 45. And something I find useful is writing out this term in terms of its prime factorization. What that means is just break it down into a product of prime numbers. And to start that, I would see, can I factor out a 2 and 45? I can't. Definitely can do a 3 though, so I can write this as 15 times 3. And keep going. Now 15 I can write as 5 times 3, so I'm left with 5 times 3 times 3. Now each of these is prime numbers, and that's what I'm looking for. So what I'm trying to do is, now that I've figured out what these numbers are, I want to take a guess and try perhaps 15 here and 3 here and see, does that work for me? So I'm going to step aside over here and we're going to take a guess. X plus, in the first blank I'm going to put 15 because that's 5 times 3, and that means the next one has to be 3. So x plus 3 is my second term. Well, definitely my last term is going to be 45, and my first term is going to be x squared, but it looks like my middle term is going to be 18x. So no, that guess doesn't work for us. But is there something that will work for us? We know we want minus 14 when we add our outside and inside terms together. That's a negative. So kind of what I'm seeing here is if I look at 3 times 3, well, that's 9 and 5. And when I add 5 and 9 together, I get 14. But what I need is I need negatives. So let's try this side. We'll try x plus negative 5. We can do that. And x plus negative 9. And sure enough, when we FOIL this back out, we get x squared minus 5x minus 9x plus 45, giving us what we started with. So you can always, you may need to mess around with the signs of the numbers that you're guessing with to make it work. Now let's take a look at the AC method. When you start to get polynomials, and more specifically trinomials, whose leading coefficient is not 1, guess and check method gets a little more complicated and may take some more work for us. So what we're going to do is try the AC method. Remember the general form we had for a trinomial. We had ax squared plus bx plus c. Now, for the AC method, we want to find two numbers, and I'm going to call them s and t, where the following two things are true. One, we want s times t to equal a times c, and we want s plus t to equal b. And the a, c, and b, they come from this general form. So my a in this case is 15, my b is negative 19, and my c is 6. So I need two numbers, s and t, where s times t equals 90, and I need s plus t to equal minus 19. Again, useful for us when we're doing the AC method is to take this 90 and write it out in terms of its prime factors. So I'm going to write 90 as, and you can check this, 5 times 3 times 2 times 3. Okay. Now I know when I multiply all these numbers together, I get 90. What I'm looking for is I'm looking for pairs of these. When I add them together, I get minus 19. So if I look at maybe 15 and 6, so I'm multiplying 5 and 3 and 2 and 3, 15 and 6, not getting too close to 19. So you can be educated about getting this 19 out. Let's try. Now I'm seeing 5 and 2, I can get 10. 3 and 3, I can get 9. Now when I add these together, I get 19. But that's just the wrong sign. So all I'm going to do is change the sign on both of these. So I'm going to guess s equals minus 10 and t equals minus 9. Once you figured out what your s and t are, you're going to come back to your trinomial. And you're going to rewrite this middle term, the bx, as the s and the t, using the s and the t. And what I'm going to do is minus 10x, so there's my s, minus 9x, there's my t, plus 6. So we haven't changed anything. All we've done is we've split up this middle term, this bx, into two other terms. And now you're noticing that I have 4 terms, and I'm probably going to start to factor by grouping, which is exactly what I want to do. So these first two terms definitely have a 5 and an x common. So I'm going to say 5x times, now when I do 5x, I'm left with 3x minus 2 For the next grouping, it looks to me like I have a 3, and I'm actually going to take a negative 3 out. So when I do that, I'm left with 3x minus, that's a minus 2. And when I took the negative out, what that did is that made this term and this term the same, so that I can keep factoring. Now, I'm going to use my GCF. I have a GCF of 3x minus 2. And when I factor that out, I'm left with 5x minus 3. And you can go and double check, and you always want to do this. Refoil this out to make sure you get back what you started with. Okay? So here we are. This one's a little more complicated. This has 2 variables, but don't let that mess you up. Now, just remember, I'm looking at a trinomial. Again, it has 2 variables, but it's a trinomial, and the leading coefficient is 6. So what I'm going to want to think about is the AC method. So I'm looking for 2 numbers, s times t, that equals minus 30, and I want s plus t to equal minus 7. Minus 30 in its prime factorization is minus 5 times 3 times 2. And I'm looking for 7 when I add them together. Excuse me, minus 7. So take a look. If I do 5 and 3, 15, I'm not going to get to 7 with that 2. But what if I do 5 and 2? So I can do 5 and 2, 10, 3, and to get me to minus 7, I'm going to put the minus in front of the 10. Again, following our procedure, we just want to split up that middle term. Oops, minus 10. So I'm going to call this s, I'm going to call this t, minus 10 xy plus 3xy minus 5y squared. Now factor by grouping. First 2 terms, I have a 2x I can factor out, leaving me with 3x minus 5y. Second grouping, I have, looks like just a y common. So I have plus y times 3x minus 5y. Finally, using my greatest common factor of 3x minus 5y, I am left with 2x